Now let's solve the numericals based on the Nernst equation. So such type of numericals are asked based on the Nernst equation. The Nernst equation which gives a relationship between the E cell and E naught cell, where E cell, that is a cell potential, and E naught is a standard cell potential if it is a cell, and if it is an electrode, then it is called as electrode and standard electrode potential. So question number 1, write the cell reaction and calculate the standard potential of the cell. We have to write the cell reaction for this. The cell is given and we have to write the reaction. Cell reaction means first you have to write the reaction on anode, then cathode, and finally you have to write the cell reaction. And then we have to calculate standard potential. Standard potential means E naught we have to calculate. So let's start with the first numerical. First, let's see the reaction taking place on anode. So on anode, I will say this is a left hand side of the salt bridge, so it is an anode, and this is cathode. So anode, it is Ni, oxidation will take place, will give you Ni2 plus 2 electron, oxidation. Then reaction taking place on cathode. Chlorine is acting as a cathode here, and Cl minus Cl is having a negative charge, and being a negative charge, simply I will say that you have to write the reaction in the reverse manner. Like generally reactant is this is this reaction, but here Cl2 will give you Cl minus. So Cl2, that is chlorine, will gain 2 electron and will give 2 Cl minus. It's a gain of electrons, so I can say that it is a reduction. On adding, let us add both the reactions. And when both the reactions are added, then we will get a cell reaction. In cell reaction, the electrons should get cancelled during the addition. So we will have Ni, nickel, it is an electrode, so solid state. Chlorine, it is going to be in a gaseous state, which gives Ni2 plus, it is again in a aqueous state, plus 2 Cl minus, again it is an aqueous state. You have in a cell reaction, right state, because if the Nernst equation is required, if we are using a Nernst equation, for example, then in Nernst equation we only consider the concentration of ions and the gases, so that time the state is must. But here we are not going to use Nernst equation because you have to calculate standard potential and standard electrodes are given here. So E naught cell is equal to, I can say, E naught cathode minus E naught anode. What is cathode here? Then simply I will say it's a chlorine is a cathode, minus E naught anode. What is anode here? Then it's a nickel. So chlorine is 1.36 minus 0.25 for nickel. After they will get finally minus will plus, that means they will get added, and you will get answer 1.61 volt. So E naught cell value will be a 1.61. So the cell reaction and E naught value, that is the standard cell potential. Now initially only I told that for a galvanic cell, in a galvanic cell the reaction takes place is always spontaneous. So E naught value for the galvanic cell, that is a spontaneous reaction, should be positive, and that's why here we are getting a positive value, because we are talking this reactions are nothing but from the galvanic cell only. The second one, the second question now, let's see. Again a reaction given, there is a reaction, represent the cell in which the following reaction takes place. There is a reaction which is going on in a cell and we have to represent it, like means we have to write in this manner. And then calculate the E if E naught is given. E naught is given and we have to calculate E. It means we are going to use a Nernst equation in this case. So first we have to write the representation. So for writing a representation, better to divide whole the reaction into two parts. Or simply I told you that while solving MCQs, no need of dividing. First you just directly see the oxidation number 0 to plus 2, that means oxidized, anode reduced, and reaction will then directly use E naught formula. So here, but if suppose let us see all the things in a step by step. So first we have magnesium. After the reaction it get converted into Mg2 plus. So simply I can say that there is a loss of electron, that means oxidation it is, and since it is oxidation, that means it is a reaction taking place on anode. 2 Ag plus is giving 2 Ag. Plus is giving 2 Ag means simply I can say that it's a gain of electron. how many electrons? 2 electrons are gained. So it's a reduction. That means it is going to be a cathode. So finally I come to know that what is anode and what is cathode. So cell representation can be written easily. So cell representation is, first we have to start with the anode. Anode, that too while writing a cell, extreme it is going to be electrodes, and in between we have to write the ions. So first with the electrode, in this here it is a first we have to start with the anode. So anode, this is the electrode and this is the ion. So it will start with the magnesium. State is Mg, solid state. Mg2 plus, if you know the concentration then you have to write concentration. It is given Mg2 plus 0.130 molar. Then 2 Ag plus, coefficients are not used while writing a representation. Its a concentration is also given 0.0001 molar, and then Ag finally, that is in solid state. So this is the representation. After writing representation, we have to calculate E. So for E, the formula Nernst equation I will use. So Nernst equation is E is equal to E naught minus 0.0592 upon N log to the base 10 molar concentration of product upon reactant. And when I am saying it's a molar concentration of product upon, okay, so molar concentration of product upon molar concentration of reactant. So here I can say E naught is given, how much it is? 3.17 volt minus 0.0592, and N is a number of moles of electron which is gain or lost, that means 2 electrons which are cancelled, 2 log to the base 10 product upon reactant. Here we consider only the product concentration of the ions and the pressure of a gas from the reactant and product. So product, the overall reaction this is. From here the silver will not be considered as it is in a pure solid state. I will consider Mg2 plus, and from here I will consider only Ag plus. So it is going to be concentration of Mg2 plus upon the concentration of Ag plus. And if there is a coefficient, then it is raised to power. So 3.2 is a coefficient, so 2 is written in a power. So here I can say 3, 0.0296 it is. Log to the base 10, Mg2 plus concentration is 0.130 upon this is 0.0001. So here I can write it's a 3.17 minus 0.0296. After all calculation you will get a 0.21. So finally we get 7 minus 1 is 6, 11 minus 2 is 9, and then 2. So it's a 2.96 volt is a final answer. That is E naught value, E value for the cell. That is cell potential. If the standard cell potential is 3.17 volt. The next numerical. Consider the following cell. The cell is Pb, Pb2 plus, Cu2 plus and Cu. The concentrations of the ions is also given. First, write the cell reaction, calculate the E cell and E naught cell, calculate delta G and delta G naught for the reaction. E naught of copper and E naught of lead, that is the electrode potential for both the electrodes are given. Now let's solve. First we have to write the cell reaction. So let's start with the first part, that is the cell reaction. So to get the cell reaction, anode and cathode reaction we have to write. On anode, here the lead is acting as anode and copper is acting as a cathode, as it is present on the right hand side of the salt bridge. So Pb will give Pb2 plus 2 electrons. Oxidation I can say here. Cathode reaction, Cu2 plus will gain 2 electron and will give Cu. That is reduction. Once anode and cathode reaction is over, the next addition of it. So let's add so that we will get a cell reaction. Two electron will get cancelled. We will have Pb, that is a lead in solid state, plus Cu2 plus in aqueous medium, which gives Pb2 plus in aqueous medium plus copper in solid state. So first part, that is A part, is over. Then second, we have to calculate E cell and E naught cell. So let's calculate first E naught cell. E naught cell, the formula is E naught of cathode minus E naught of anode. Here the cathode is copper. So E naught of copper minus E naught of anode. Anode is lead. So E naught of copper is 0.337 volt minus E naught of this is minus 0.126. This will give you 0.463 volt. So first part of the B is over. Then we have to calculate E cell. E cell, that is a cell potential. Once I got E naught, so if the E naught standard electrode potential is given, then from that we can calculate standard cell potential. If E value is given, then we can calculate E cell. So from standard value we can calculate only standard cell potential. To get that E cell now, we are going to use Nernst equation. So Nernst equation, E cell is equal to E naught cell minus 0.0592 upon N log to the base 10 molar concentration of product upon molar concentration of reactant. So it is equal to E naught cell. E naught cell is 0.463 minus 0.0592 upon N. N is the 2 here. Log to the base 10 molar concentration of product. Product is, now from product we have to consider again only the concentration of ions, not pure solid and pure liquid. So ions is Pb2. It is in a liquid state, but it's not a pure liquid, but it is a mixture. So mixture can be considered. So Pb2 plus ion concentration from the product upon, from the reactant we have copper 2 plus ion. So this will give you 0.463 minus 0.0, after dividing by 2 you will get 0.0296 log to the base 10. Lead ion concentration is 0.5 molar upon copper 2 plus is 0.001 molar, that is I can write 10 raised to minus 3 also. So it will become log of 5 into 10 raised to 3, that is 5000 also I can say. So after solving this whole, you will get a number that is 0.383 volt, that is 0.463 minus this into log of 5000, multiply. If the log is given in a formula, then its anti-log is not taken. So log of 5000, whatever you will get, multiply it with 0.0296. And after calculation, you will get 0.383 volt. That means we completed the second part also. Then third part, we have to write the delta G and delta G naught. So for delta G, the formula is minus NFE cell. Again, N is the number of electrons. So 2 electrons are gained and lost here. F is the 96,500. E cell I got 0.383 volt. After all calculation delta G, you will get minus 73,920 approx, this much joules. Then delta G naught, which is formula will be minus NFE naught cell. Again, that is minus 2 into 96,500. And E naught cell is 0.463 here. After calculation, you will get minus 89,400 approx joules. So finally we got delta G and delta G naught also. So the first, that is a cell reaction, then E naught and E, and then delta G and delta G naught. The next numerical we have, calculate the equilibrium constant for the reaction at 25 degrees Celsius. Strontium plus Mg2 plus gives strontium 2 plus Mg. We have to calculate equilibrium constant. Equilibrium constant means we have to calculate here K. So E naught values for the magnesium and strontium is given. So let's start with the fourth question. So for K, we have a formula E naught cell is equal to 0.0592 upon N log of K. So for this I require E naught. So E naught of cell is equal to, is equal to E naught of cathode minus anode. So here first we have to decide what is cathode and what is anode. So here I can say strontium 0 to plus 2, that means it undergoes oxidation, so it will act as an anode, and this is reducing, so it is a cathode. So E naught of magnesium minus E naught of anode is strontium. So E naught of magnesium is given as minus 2.37 volt minus of 2.89. So finally it will become minus 2.37 plus 2.89, which gives 9 minus 7 is 2, 8 minus 3 is 5, that is 0.52 volt. So we got E naught cell. So E naught cell once I got, then I will use the formula E naught cell is equal to 0.0592 upon N log of K. Now here in this case I can say that total number of electrons, strontium is losing 2 electrons and magnesium is gaining 2 electrons. So total electron gain or lost is 2. So here I can say that it is 0.0592 upon 2 log of K. And E naught cell is 0.52. So log of K is equal to, we will have 0.52, and this will on division give you 0.0296, which is shifted here, that means 0.0296, and when you divide it you will get 17.56, that is a log of K is equal to 17.56. I want K, so taking an anti-log on both sides, so anti-log of 17.56. So anti-log of 56, 17 is a characteristic, so will raise to power of 10, and anti-log of 56 is 3.69. So 3.69 into 10 raised to 17 is the value for the K, that is the equilibrium constant. Now let's see the question number 5 now. Using Nernst equation, calculate the potential for the half cell. We use the Nernst equation for a complete cell. It's a half cell, means only oxidation or reduction. So reduction value is given. I said that Nernst equation can be used for electrode as well as can be used for the cell. So here we are using Nernst equation now for electrode. E naught is given and we have to calculate potential, that is E. So the formula will be E is equal to E naught of electrode minus 0.0592 upon N log to the base 10 molar concentration of product upon molar concentration of reactant. So it can be written as E naught minus, E naught is given, it's how much, 0.535 minus 0.0592 upon 2 log to the base 10 molar concentration of product upon reactant. That means it's a log of only the product is I minus, upon on the product side there is a no reactant, so it's only 1, so we'll give you 0.535 minus 0.0296 log to the base 10 3 into 10 raised to minus 2. 3 into 10 raised to minus 2 it can be written, and 3 into 10 raised to minus 2 is 0.4771, and this is minus 2 log of 10, that means it will become plus, and after solving all you will get a number that is 0.625 volt. So this will be the answer, that is fifth answer, question number for the 5, E value.